If you're going to work with text, you'll be using the string class. A string is a series of characters, and the system.string class allows you to work with the text stored in characters. One thing to note is that strings are immutable. How does this affect you? It's just that once you have text in a string, you can't change it without copying it to a new string. And this is a time and memory intensive operation. Strings are also objects, which means they're null or nothing until you assign them a value, and they have properties and methods like other objects. It's also important to note that string values are greater than null or nothing. So if you compare them to null or nothing, the values always compare greater if there's something in the string. In addition, strings are indexed, and the index starts at 0. You can refer to the items in the string by position using the index that starts at 0. Even literal strings are objects. If you want, you can enter a literal string in Visual Studio, press dot, and you get IntelliSense that shows all the methods and properties of a string. So literal strings can be treated as normal objects in Visual Studio. The .NET Framework maps language intrinsic types to .NET Framework types. For example, the .NET Framework system.int32 type is the same thing as the C# int type. So if you're in C#, you declare a variable as type int, it's the same as declaring it as a system.int32. The same for a string. The system.string type in the .NET Framework maps to the string type in C#. So whether you create a string with a lowercase s or a system.string with an uppercase s, you end up with the exact same data type in your code. There are several different ways you can create strings in your code. You can simply create a variable and assign its text on creation, or you can do it in 2 lines. You can create the variable and then assign the value some other time. You can use the string class's constructors. 2 of the constructors use character arrays, and you won't use those until you're more advanced working with the string class. A third is very useful and lets you build a string from a character and the number of repetitions you want. You could, for example, create a string that contains 35 spaces by passing into the constructor the space character and 35, the number of repetitions that you want. Well, rather than talking about strings, let's look at some examples that work with strings and try out various methods and properties of the string class. I've loaded and run the sample project for this section named Strings and Dates. I'll click the Work with String buttons and we'll single step through the code. I can enter any demo text I want, but enter some text here is as good as any. Let's step into our code. The first thing you'll see is a number of examples creating strings. We can create a string named name and place a value into it here, or we could do that in 2 different lines of code. Now we can also call a constructor for the string class. Here, we'll call the convert.toChar method passing in the string a, and we'll say we want 30 of those. Once we're done with this, if we bring up the output window, you'll see that we have 30 A's in the output window. Now let's look at some properties of strings. Let's, for example, retrieve the text of our text box on our form and store it into our demo string. The length property tells us, obviously, the length of that string. If we look in the output window, 20 is the length of that string. Now let's iterate through all the characters. Because the characters are indexed, we can simply indicate which character we want at a time. This one's going to loop starting with I is 0. As long as I is greater than the length minus 1, iterate through going positive. Let's write out into our output window the demo string at the index I. We run full speed, and now in the output window, you'll see there is the output text, which we outputted 1 character at a time. The next line of code inserts a line break into the output window. Okay, next, let's retrieve a particular character. The fifth character is DemoString index 4, to prove a point that the index starts at 0, as you might expect. And of course, if we look in the output window, we see the fifth character is R. Now we can also use a for each loop to iterate through the characters, because string implements the IEnumerable class, which allows us to use a for each loop on its contents. So if I put a breakpoint here, just let this rip, we'll do a for each character named ch in the demo string, print out the character and a space. And now in the output window, we have the characters with a space between each one. Let's look at some of the methods of the string class. I'll start with a string whose contents are hello in mixed case, a string that's hello in uppercase, and one more string with a little more text in it. Let's try comparing strings to each other. The compare method allows you to compare two strings. And note here, we're calling string.compare. This is a static method. It doesn't require you to create an instance of a particular string in order to compare it. The compare method is a method of the string class. It's static, so you just say string.compare and pass in the two strings you'd like to compare. You can compare case sensitively. Let's try this. So string.compare string 1 and string 2. In this case, if we go look at the output, returns -1, which means that the first string was less than the second one. Let's now perform the comparison in a case-insensitive manner, and that returns 0, which means they compared equally. Finally, let's do a comparison where we only compare a subset of the string. Let's compare string 1 starting at 0 to string 3 starting at position 5. We'll take the length of characters in string 1 as the length of characters to compare, and compare case insensitively. If we do that, if we compare this and this, case insensitively, we should get 0 back, meaning that they matched. And they did. We can also use the compare ordinal procedure, which compares without taking into account locale information. This will always be case sensitive, and it will tell us the difference between the strings. So here, compare ordinal will just compare the byte values of the strings. Here, string 1 and string 2 are separated by just the difference between a lowercase e and an uppercase e, which is 32 in ASCII characters. So this one returns 32. If we go the other way, this returns -32 because they're comparing in the other direction, where we're comparing here an uppercase h to a lowercase h, as opposed to a lowercase e to an uppercase e. In any case, this returns 32 for the first one, the difference between the two, and -32 for the second one, the difference between the two. We look in the output, and there we go. Let's try the concat method. The concat method, again, is a static method. You just call string.concat, and then the strings you'd like to concatenate together. Interestingly enough, if you pass in an object, the concat method will call the toString method of that object to convert it into a string. This ends up with hello, 15, hello Tom, hello there. So we concatenate together all our strings with a 15 in the middle. And concat can accept as many parameters as you want to specify to concatenate the strings together. There we are. The format method we've seen already in this course, but here are a few more examples of it. Here, for example, we are going to take demostring.length and demostring and replace these placeholders with those values. If we look in the output, it says there are 20 characters in, enter some text here. Great. We can take today's date and return it. Here you can see that we take datetime.today, format it as a date, and display the information. There are a number of built-in formatting characters for dates. Here we're using the standard short date format, and we'll see in the output today's date. We can also create our own custom format specifier, 2 digits for the year, 2 digits for the date, and 2 digits for the month. Let's run this, and we'll see in the output, there we go, a date formatted in a different sort of layout. Now here we can even go farther. We can take two double values and multiply them and display all of the values in different formats. G is general, F is floating point with 5 decimal places, and C is currency. And our output will see general, formatted with 5 decimal places, and currency in the output. Another useful method is null or empty. This one returns true if a string is either null or contains an empty value. Sometimes you don't know which one it's going to have. So here we'll compare string 1, string 2, and string 3 called in isNull or empty. Again, a static method of the string class, which means we don't call it as a method of a particular string, but of the string class as a whole. We'll call string.isNull or empty for string 1. Well, it is. How about for string 2? Well, it is. But string 3 is not null or empty. Finally, let's look at the string.join method. String.join says, let me take a delimiter and an array of strings and join them back together. We're actually looking at the split method here too. Split is not a static method, it's an instance method. You call split on a particular string. Here's a literal string. I can call the split method of that literal string, and by default, split will split based on spaces in the string. You can override the behavior and have split on other delimiters, but for now I'll split based on spaces, and then join the bits back together using the join method, using a vertical bar as the delimiter. Of course, I could have easily done this just by replacing spaces with a vertical bar, but let me go with it for now. And we'll print into the output window the results, which is each word in the original string stuck back together using a vertical bar as the delimiter. So we've looked at several of the different static methods of the string class, along with some properties of the string class. The string class provides a number of different instance methods. An instance method requires you to create an instance of the string class and then do work with it. You create a string and call a method of that particular instance. Calculating length, for example, requires a particular string. You can't call string.length because that doesn't make any sense. You call your own personal string.length to retrieve its length. Now it's important to remember that methods that modify a string return a new string. There's never a case where methods of a string class will modify a string in place. It will always hand you back a new string, and that operation can be both slow and memory intensive. We'll see how to work around this once we look at some instance methods of the string class. On the switchboard form, I'll select String Methods, and this brings up a form you can use to investigate various methods of the string class. For example, the trim method. It accepts this string, and here you see the parameters. Now for the trim method, you can specify either nothing at all, in which case it will just remove spaces from either end of the string, or you can specify an array of characters. Here I have THE space DOG. It'll remove THE space DOG, any of those characters that it finds from the end of the string. You can see we end up with quick brown fox jumps over the lazy because it removed THE space from the left and DOG space from the right. The order of these characters doesn't matter, so I could put here, and it wouldn't matter. We'd get the same results because it's using all of those characters for things to look for. G's in the list gets removed. O's in the list gets removed. D's in the list gets removed, and so on. I could add, for example, Y and Z to this. Now if I recalc it, you see the Y and the Z at the end get removed because they're in the list of acceptably removable characters. If I remove the Y, however, we remove neither the Z or the Y. It removes G, then O, then D, then space. It gets the Y. Y's not in the list. It stops removing characters. So the trim method allows you to trim things off the end and the beginning of another string. You can use other methods to try different things. For example, The index of method allows me to determine where the first index of O is in this string. Now, if you don't want to count, you can click pause and bring up this little dialog box, and it'll show you that Brown has the first O at position 12. That's 0, 10, 20, 30, 40, and so on. So you can use this little dialog box to determine if the answer is correct or not. Have fun playing with this form. It allows you to try out most of the instance methods of the string class. Remember, an instance method requires you to specify an actual instance of a string, dot, the name of the method you want to call. Here we're using this as our instance and calling the index of method to find the first location of the letter O within that string. I've said this several times already, but strings in .NET are immutable. Every activity that modifies the text in a string returns a new string back to you. You pay a serious performance price for making multiple modifications to the same string, or a series of modifications to a string. The String Builder class takes care of this. It maintains its own buffer, and it grows as necessary to accommodate changes. It can be more efficient than the standard string class. To retrieve the contents of a string builder, you just call the toString method, and it hands you back the contents, the string that it contains. Now note that the string builder isn't magically faster than string. It only helps you when you're performing multiple operations that modify the string. As a matter of fact, I don't even bother with string builder generally unless I'm performing a number of operations, usually inside a loop on the same string. Now it can be useful for other things as well, perhaps when you're concatenating text together. Rather than appending carriage-return line feeds yourself to output text, you can use the append line method of the String Builder class. So imagine you want to display a list of files in a folder using messagebox.show. StringBuilder.appendLine makes this easy. You just look for each file, and after you find each file called StringBuilder.appendLine, to append the line to the output buffer, and when you're done, you just retrieve the results, which will be all the files, each on their own line of text. You might want to investigate the String Builder class and how it works. Well, the class maintains a buffer, starting with 16 characters in it. As necessary, the String Builder doubles the size of that buffer. It goes from 16 to 32 to 64 to 128 characters and so on, so there's always room for more text as necessary. You can, in the constructor, specify the starting size. If you know 16 won't be large enough, you can specify the size when you create the String Builder. You can check the capacity property to see the current size of the buffer. You can check the length property to see how much text is actually in the buffer. And you can check the max capacity property to see how much text could ever be in the buffer. That's fixed for a given operating system. Let's try a demonstration that works with the String Builder class. I'll click String Builder on our main form, and I'll single step through code, and here we go. I have here a string builder that contains the text, "The fox jumps around the dog this afternoon." I want to replace around with over. I want to replace this afternoon with nothing at all. I want to insert Quick Brown and insert lazy. So we end up with, as you might guess, the quick brown fox jumps over the lazy dog. Now using strings, we'd have to make these modifications and each time return a new string back. Using the String Builder, we might be able to do this more efficiently. Well, the String Builder class has a replace method. Just replace around with over. It doesn't return back a new string, it does its work in place in that string. Now I'd like to remove the this afternoon string, so I'll remove, starting at the length minus the length of this string, removing this much stuff from the string. Again, it does it right in place without returning a string back. Index of, however, is not a method of the String Builder class, so I need to get the string, find the index of the word fox in that string, and then insert into the string builder at that position the word quick brown space. I need to find out where dog is, and there insert the word lazy. So we now have made multiple modifications to our original string, and if I retrieve the toString method of that string builder, I should get back the results we wanted. Was it faster in this case? I really doubt it, because we accomplished such small modifications. If you're doing modifications in a loop or had thousands of modifications to make, certainly I would have to believe that using String Builder would be easier. Let's try my second example, which is to iterate through all the files in a folder, and for each file, there won't be many in this folder, it's not a very interesting folder actually, for each file we get, and we'll discuss using directory info and get files in a different section of the course. For each file we find, we're going to append a line to the string builder using the full name property of the file we found. Try another one. Is there another one? Oh yes, there were more than one. Good. We'll append each one on a new line, and we should see the results. Are we done yet? I think we're done now. Oh, one more. There's more. Well, clearly we need to set a breakpoint right here, run full speed to there, and now we'll see a list of all the files we found, each on its own line, which we built up by calling the append line method of the string builder. Now we can retrieve information about our string builder. Let's create a new one, and let's retrieve its capacity, length, and max capacity. We'll do this by using the append line method again, and we're getting information about SB, which was our old string builder, which had all the file information in it. What do we get? We get its current capacity is 256, the length of the current string is 163, and its max capacity is around 2 gigabytes. Certainly big enough for any string you're likely to have to build up yourself. So therefore, the string builder can save time and effort when performing multiple operations on a string, or if you need to append items into an output buffer and then display that output buffer with multiple lines of text.